Hello, this is part 2 of section 1.3. We're going to continue on about writing equations of the line, and today is about parallel and perpendicular lines. And this is the essential question. All right, parallel lines. Two lines that in the same plane, that do not intersect. And if they're parallel, then their slopes are equal. Something that you learned in geometry and maybe reviewed again in some other classes. So if you're looking at this, I'm saying that L is parallel. So L is here. L is this line here. And it's parallel to this other line here, right? There. Okay, so how would I write the equation of a line for L? Well, I have a point, 3, 3, but we remember that y equals mx plus b, we need the m and the b. I need one of them to be able to find the other, since I have the point. Well, since I know they are parallel, again, the statement says, if they're parallel, they are, then the slopes are equal. So this slope for this line m equals 2, and since L is parallel, L also has a slope of 2. But we can't determine the y-intercept. It's hard to see in this graph, so I'm going to use the equations right there. And we've done this before. We're going to be substituting in, and we're going to solve for b. And then you have your equation of a line. And there you are. What about perpendicular lines? Okay. So if you remember, perpendicular lines that intersect at 90 degrees or right angles. And the theorem states if two lines are perpendicular, then their slopes are opposite reciprocals, or their product is -1. So again, we have that same line here, right? That's 2x. But now L is perpendicular, right? L is going this way, is perpendicular to that line. So that given line, the slope is still 2. But then what would be the slope of L? Now you can see that this line here is positive. But you can see that L is going down and it is negative. That's why they're opposite. So graphically you can see if one's positive, the other one has to be negative, and vice versa. And then it's the reciprocal. So the slope of L, and I'm going to do slope with a capital L, subscripting slope of line L, is -1/2, having that reciprocal, right? And going to use that point right here. So I have y equals mx plus b. This time I don't think I'm going to clear the fractions. I'm just going to add a half, because 2 plus a half, 2 apples and half an apple, that's 2.5 apples. All right. So y equals -1/2 x plus 2.5. I can change that to 5/2 to have simple fractions. All right, and there you are. What if you're not given a graph? Right? These problems should look similar to the ones that we've done before. Let's read. Slope-intercept form. And now what are we given? A line that's parallel to it and containing that point. All right? So parallel means same slope. So this is m equals 3. So our new line that will be parallel to this given line will also be m equals 3. And I'm going to use this point in our equation, right? Slope-intercept form. And again, we're just going to simplify and solve for b. And then write our equation, don't forget, because that is what it asks for at the very beginning. What about perpendicular? All right. So it's still asking for slope-intercept form. Still gives us a point. Now, if it's perpendicular, we are looking for the opposite reciprocal. Okay, so first of all, if it's here, y equals -7. What kind of line is that? Well, the slope is 0. That is a flat line, a flat horizontal line. So what would be perpendicular to 0? Well, if you're not sure, I'm going to quickly sketch. Hopefully some of you may know. If it's a horizontal line and it's going through this point, that would be 5, 1 would be about here. So if it's perpendicular, right, if it's horizontal, it would be vertical. Right? And if I'm given a vertical line, the perpendicular line would be horizontal. All right, so if this is a new line, what slope is that? Well, if this is 0 slope, this would be undefined. And we remember that's a special line. We talked about that last time. So then our new slope here, the opposite reciprocal, the slope would be undefined. And because it's undefined, then I know since this is y equals -7, this would be an x equals. And since it's going through this point, it has to have the same x value. So equation of this line would be this. All right, take a moment to look at the directions. Parallel again, but this time the equation of the line is not in slope-intercept form, it's in standard. So I have to find the slope. And to do that, I'm going to put in slope-intercept form. Okay, there we go. Again, parallel is same. So the slope here is -3/2. Containing that point. You know what? I think I'm going to clear the fractions just to get you guys to practice that. It will come in handy, so the more you get used to it now, the easier it will be when we deal with more difficult fractions. Please remember when you do this, some of you are forgetting to multiply the 2 times the b. Oops. So I added 3 to both sides and divide. So my equation is -3/2 plus 11/2 or 11/2. So let's try one that is perpendicular, but also again in standard form. So we're solving for y. And just being careful, negative and a positive. Trying not to go too fast. Okay, so it's opposite reciprocals. So the slope for here is 5/4, but remember we have to change it. So it's going to be -4/5. Containing that point. Okay, so -6, -4/5 over 3 plus b. I'm going to clear the fraction again, that 5. A little bit more complicated. Adding 12. Okay, that's going to be -18. If you needed a calculator, that's fine. Dividing by 5 here. Please don't write decimals. Leave it as a fraction. It is more accurate. So y equals -4/5, x minus 18/5. Okay. Now sometimes we're given two lines and it's not graphically, so algebraically we need to figure out are they parallel, perpendicular, or neither. So remember, parallel, same. We're looking for same, opposite reciprocals. And if it's neither of those two, if it's not one or the other, then it's neither. All right, so if we're looking at this, all right, the way to compare is if they're both in slope-intercept form. So you can see the slope. So that one is, I'm not going to worry about that one, but I'm going to rewrite the second one here. Negative 2y, negative x, plus 8, dividing by negative 2. Okay. So y equals half x, negative 4. Okay, so let's compare. The first slope was 2. The second slope was a half. Okay, are they the same? No. Are they reciprocals? Yes. Are they opposite reciprocals? Well, they're both positive. To be opposite reciprocals, they have to have opposite signs. So it's neither of them, so I'm going to just write neither. That's how you know, because they're not equal and they're not opposite reciprocals. Just reciprocals, but not opposite reciprocals. It needs to be both. All right, so for this one, neither of them are in slope-intercept form, so I have to change that. Okay, so that's the first, oops, pressed the wrong button. The second one. Divide by negative 1, 3x minus 10. All right, let's compare. So this first one was 3. The second one was also 3. That tells me what? They're the same. Same is parallel. So lines are parallel. I hope you remember that symbol, parallel. All right, so that's how you show them algebraically. All right, don't forget to answer the EQ. Until next time, class, be safe. Bye.